Yeah. And now we are going to do the panel debate, and we are so lucky to have the moderator, Kjell-Einar Eriksson from DNV.
Jeg må få på mikkene før de starter.
Ok.
Han klarer ikke å gjøre to ting samtidig. Eller han gjør egentlig tre ting nå.
Yeah.
Vi må få mikkene på før de får starte.
So we will.
Så får vi ikke opptaket skikkelig.
So in English we need a couple of minutes for the texting. Good. Yeah, Siemens and Aucotec, the ones who will have a mic, they need to come over here now.
I will see if they are at the booth.
They're not here? Okay, skal vi bare starte?
Okay, vi starter bare. Ja. Ja. Okay, we need to be flexible, so since they're not present, we will kick off this interesting panel debate. We are so lucky to have Kjell-Einar Eriksson here with us today from DNV, who's going to be the moderator. Big applause. And then we are lucky to have Pedro Nunes from Aker BP. Big applause. Geir Aarvik, Aker Solutions. Per Christian Weiberg, Equinor. Jon Grestad Theodorsen, Chair Post-Caesar Association. Ellen Kristine Karlsen, Able. And Yngve Nilsen from Offshore Norge. Yeah. And now you have to be ready for this, because this team over here, our technical team, they will also score and evaluate you guys. Oh, no. A little bit of a joke, but maybe they will as well. Okay.
Thank you very much. Do you all hear me? Yeah, it works. And to the technical committee, we of course expect nothing but the best panel ever after this show on stage. But bringing us back to DISC, and here I have to read a bit, the DISC objective, that's to achieve seamless, standardized, secured, and verified data flow, enabled by PCA library services to accelerate project execution and streamlining operational procedures for greater efficiency. So that is what we are going to debate, and also what we've heard today about these marvelous technical solutions and systems that we've heard about. Now, to set the stage a little bit, I'll start by giving some facts from an annual survey that DNV does. So every year we talk to 1,300 executives in the global energy sector about how the sector is evolving, anything from oil and gas to hydrocarbons to hydrogen, renewables and so on, and also about digital. And we asked them what are, for example, the biggest barriers that they face. And on the top 5 list, we have resistance to change, cybersecurity risks, data quality management issues, cost of digitalization, and lack of digital skills. So that's the top 5 barriers. Worth noting that when we did this in 2023, data quality was not on the top 5 list, so that has come up, and there is probably a reason for that. When you ask the industry about investments, they say optimizing processes, integrating systems and databases, automating operations, predictive maintenance, and strategic analysis. That's the top 5 priority areas for the digital investments. And as I guess all of you noticed, and on the long list of priorities, no one said ontology, no one said information model, or LCI, or interoperability. So I'll start sort of throwing that to the panel. What can we do to make ourselves more relevant on an executive level? Anyone would like to start?
Yeah, it's on. Yeah, so I think what we are doing here it's extremely complex. And when we use terms like ontology, IMF types, etc., it's really, really hard to make that leap from what is this toward what I need. And it even sounds a bit like science fiction. It's too complex, there's no way we'll get there. So I'll give a kudos to Tonje. The guy who stood at 10 years ago, scrolling to his phone. That was kind of one of the light bulb moments for me today. So this is how we need to present it to the executives. Right? They need to understand what we are trying to do. If you can couple that together with the quality part, which they already are interested in, I think you are going somewhere. Then it will be easier, I think, for the executives to understand it.
Anyone would like to continue on that topic?
Yeah, I can try. You know, it's the term. Maybe it's not too flashy. You know, it's not visual, so it's kind of difficult to communicate. But I would like to recommend to connect it to real use cases, so that the management also can see the value in it. There is the value.
Yeah.
Yes. Oh, thank you. I can just add that at least in our case, in Aker BP, even having a CEO that is very digital savvy, this is a need that they recognize. And then most of the case is just show me the money. Show me what this is going to make to my business, and then you are talking the same language of the business owners, right?
Yeah, I agree what's said here as well. And I think showing what some has been showing today, where you have live data, where you have real system that is operational already and you utilize it in a smarter way, I think that's one way of doing it, absolutely. Because then the C-level can also relate it to the operation part. I think that's very important.
So we'll take that as a sort of encouragement to everyone on sort of how are we pitching this and what kind of words are we using, showing it in the business context. Another barrier when we ask our clients is cost of digitalization, cost of implementing new technology. And obviously if we are to do this right with sort of all over the infrastructure, this is very costly. So some reflections on how can we implement new ways of working or new ways of implementing this technology in an efficient way, and maybe some examples.
I think, first of all, taking case by use case is very important. Not try to implement everything at once, doing it step by step. And I think we have one very good example on a use case that has been successfully implemented. And then that is the use of AML, Automation Markup Language Technology, to exchange automation information between the suppliers, us as contractors, and also the end users. And it has been started with just a few, and now it's implemented, I think, almost all over the main industry, at least here in Norway. So I think that is a very good example, and we see that it is benefits for all the users. So I think that is something we could also market and sell as a successful history.
And maybe for the ones who don't know that case so well, how did that start? And what was there a light bulb moment with that one?
Okay. No, it started with Equinor. I think it started with Equinor and maybe Aker and Kongsberg. On DP, or before DP, Johan Sverdrup DP. And then we took over the EPC contract, developed it together with Kongsberg further. And then it has been deployed through the Sverdrup process, the next phase 2 project. And now also is used all over Yggdrasil. So it's, yeah.
At the end, John?
Yeah, I think one of the keys here is to not focus on the digital. We know that digital is key, but focus on the use case and then apply the digital elements and the standards and how we can solve these use cases. What is unique to this collaboration is that we collaborate across the industry, and I think that is unique. And also you see all the solution providers today showcasing what they do in front of their opponents. That's quite new, And this will help us as an industry be competitive going forward.
Yeah, and Jon, I think you stole a little bit of my argument as well about collaboration. So coming from Offshore Norge, we want the industry to collaborate about different initiatives and so on. And EQ Hub that has been mentioned a lot here today is a good example as well, I think, as a success story, still development and still developing, but I think it's a success where we can see that the whole industry has gone together and agree that this is something we want to do and achieve, and we can see actually live use of that now in a quite complex world if you describe it from the academic side. So I think collaboration is very important, I think.
And if I take an international perspective, I would say that the Norwegian continental shelf is pretty unique in that way. So the collaboration between the operators, the engineering or integration side of things, and the authorities, and basically moving towards a common goal. I mean, we do not see that in many other parts of the world. So I guess sort of building on that, which has been a sort of a clear mark of what's going on in Norway on the continental shelf, is something we should continue to build on. Yes.
The comment there, I think the AML case is quite interesting because I believe we still, require PDFs on SEDs. So there's a lot of, work processes still relying on that PDF. But we have taken it step by step and do it or require AML as a first step.
And maybe sort of then I may throw in that on the top of the list of barriers was resistance to change. Is that an example of resistance to change? Not ready yet, or?
No, of course, culture is a really important aspect for implementing change. We see that every day when we work with digital. People have worked this way, for 30, maybe 40 years, reluctant to change. But what we need to do is to work together with the business. These developments cannot be something on the side. We need that pull and engagement from the business as well to succeed.
And we sometimes also say that we don't want to change because we do it safe and efficient on the Norwegian continental shelf. But I think it's possible to do it safe and efficient, but also more cost effective. And I think that's where the digital part is key, and everything that we have seen today will help us into that direction.
I can just add as well that, yes, if it was not that difficult to change, maybe the implementation cost wouldn't be 4 times higher than development cost, because it takes much longer time to implement things that we expect when we're building a solution. And then when you see the business case from digital initiatives, very rarely you see the cost of that really going to take to implement this. So I think that working with the organization, working with the culture for change is definitely a good investment to make that transformation cost reduce.
Yes, I have to be quite honest. I don't really like the term resistance to change, because if you look at a lot of what we're developing, a lot of what we're doing, we are taking parts of a process or part of a system, and then we implement and we make an improvement. However, for the end users, the engineers, they still have to do a lot of their works similar to what they have always done. So as long as we don't take the end-to-end part, they will still have all these kind of aspects of working as they've always done. So if you put yourself in that shoe, it isn't really a big change. It's some new tools with some new colors, but I still have to deliver the PDF. So I think we are a bit quick to term that into resistant to change. I think we really need to explain it together with them. As you said, yes, now you actually get this part of your work better. We are not improving everything at once, because as you said, that's not possible. You have to take piece by piece by piece. So it's in our communication as well, when we try to implement something.
And maybe that is also a way to getting better attention at higher levels, at sea levels, if we then, it's not appreciated or sort of something that will, that has a lot of resistance, because We are gradually improving things. That is what I hear. Okay, let's jump a bit to artificial intelligence. I mean, it's a digital conference. We have to talk about artificial intelligence, hype or not. The work that's being done in DISC, how can that be improved by AI, and how can it help improving AI? Which question do you want to start with?
Yeah, I guess how it can be used in DISC. I think AI, we've been working with that and tested it and so on. And I guess when we can succeed with it is when you have structured data according to standards and so on. Then we see that we can actually get some effect out of it in an efficient way. So I guess that was also shown here today, that when you use structured data, when it's in a certain pattern, then you can get a lot out of it, I think. And I guess that's what DISC should work on further, to look at the standardized data and get the result out of that.
And that has actually been part of the work that we have done in DISC for many years, to start to work with standardization, utilizing standard languages and the IMF models to create this standard foundation and work underneath the panzer in Norwegian for a while, because that is the basics to be able to use the AI. We will not be able to use it if we don't have quality in the bottom, in the cellar.
I think it's interesting in the last presentation here to see that you can use AI to actually build a foundation for AI as well. That's really, really interesting.
So, yeah.
I can just add, because I think that the best knowledge, at least for me, that makes sense, that AI is this really new graduate student that you get in your team to help you, and is super smart, is willing to give you all the answers, but doesn't have the experience, doesn't have all the connections in the company. And what you're doing here is really create that connection for that AI that you want to implement to be quite smart and be able to give you the right answers.
So maybe communicating this as an enabler for successful implementation of AI, to build that under the bonnet or under the hood, with respect to having structured data that you can really work on and thereby creating value. Maybe a way of communicating to get C-level attention as well. And as I mentioned, the fact that data quality is creeping up on the list of a challenge. I think going back a couple of years ago on conferences on digital twins, no one talked about the data quality. Everyone talked about these digital twins that could solve absolutely everything, right? And nowadays, any conference on a digital twin has a lot of presentations on data quality or the lack of it. So maybe that is the sort of segue into getting more attention for what we are trying to do. If you don't get this right, the digital transformation journey will be even more expensive, and the AI investments will be even higher. Okay, if I take us back to what we've heard so far today, a series of interesting presentations. Any reflections from the panel on what people have presented?
Yes, as the overall responsible for EQHub, I'm very happy to see that everyone now is using and utilizing the data. So that was very nice for me to see. 1 year ago, we opened up the system for everyone to use. So I'm very happy to see that it's now working. What we talked about and what I wrote in a business case of 50 pages in 2018, now we can actually see, the proof of what we predicted. So that's very nice to see.
Yeah, very impressive kind of demos, really working prototypes. I really love this way of showing progress, because you get to kind of granularity that you need to identify where the problem actually is. Otherwise, you're just talking kind of across each other and then very high level, and then nobody gets anything done. But when you do the prototypes, you say, hey, this is what we have to fix, guys. And I think that makes a lot of sense. Also for the audience that's looking to the work that was done by you.
Yes, I completely agree. And I mentioned the light bulb moments. The presentations today show that we are actually there, right? You can connect all the data, show different views, you can import them, use all kind of technology to get there, but a lot of the foundation have already been made. So make it something that is not science fiction, show this, that what can actually be done. So I've been really impressed that you can stand here live on the scene and actually show what we are just talking about elsewhere. So really impressive.
Any comments from you, Jon?
Yeah, I think it's impressive how the limit has been pushed just since December. And from the technical committee, the challenge that went out to all the companies and how they have prepared, obviously used a lot of hours to prepare these demos and able to showcase it live is as mentioned, very impressive. And then as Webstep said under their presentation, there is nothing stopping us at the moment. It's up to us, the expert from the operator companies, to go back home together with our contractors and make this work. So that's the winter challenge for 24-25. And maybe we should demo next year to the suppliers how we do it.
Yeah, that's a good one. A reverse conference. The operators demoing to all the tech providers. Okay, we have a challenge there. Yeah, are you up to that from Equinor?
I'm not available that day.
No, exactly. No, exactly. No, I know. So I mean, you are post Caesar, so you are free in this panel. So asking Per Christian.
I'm also busy that day, I think. No, but kudos to all the presenters. I think it's been fantastic to see also the width of the presentations. And I think also many of the presentations kind of complement each other, both technically and on more standardization aspect. And I'm really excited to see what we actually can do after looking at what have been showed here.
Okay, coming into the last part of the panel discussion and basically then so that everyone remembers, repeating the DISC objective, which is to achieve seamless, standardized, secured and verified data flows enabled by PCA library services to accelerate project execution and streamline operational processes for greater efficiency. Given what we have talked about here and what we have seen so far, are we getting there?
In 3 words?
In 3 words, if you can.
Yes, and definitely.
Okay. You may use more than...
First of all, I would like to say it's really a very high engagement. And I think from every time we have these sessions, the engagement increases. And the level of details we get to show, the level of data or solutions you present that is closer to our vision is there. So thank you. Yes, from me as well.
Yes, and I think also to succeed going forward, I think this collaboration environment is important. And also one thing is also related to standardization, to finally get together and agree on some standards that we are going to use, because I guess that's from what we have seen is that's a showstopper to be able to do what we have done today, I think. So we'll also emphasize that that's something that everyone has a focus on, and not to move into these religious wars where you have your own standard and do the fight for that, but look on the bigger picture, what's actually important in this case.
Yeah, I think I would say yes. Lots of progress. If it's 3 things I would mention, it is still focus on the business value, the use case, continue the innovation part, which we need for new ways of working, and also collaboration, and maybe also collaboration with other parts of the industry or other industries as well. We saw LTI Mindtree mentioned subsurface. There's a lot of interesting challenges that they also have in those domains.
Yeah, I would say it's a yes too, but it's not like a short sprint. It's really a marathon here. So it's really great to see that we're getting some wins under our belt here, because it's necessary for keeping the energy high, to attract more people, to get more enthusiasm. That's how we're gonna win this marathon at the end.
Yes, we are. I think it's a win for the DIS collaboration that we are now talking about functionality and how to integrate it, and not only ontology and semantics. That's a huge step forward just in a couple of years. So very impressive.
Thank you very much. Yeah, so we got some ideas of how to talk to the executives to sort of continue this important work. Some ideas of that, or clear message that this makes sense. It will help us also on the AI transition that we are going for. So I suggest we close it at that. Please give the panel a big hand for sharing their insights. And yeah, was it the best panel debate ever, or what's the score?
I'm super impressed. Very good.
Thank you, Jan.
Thank you.
Ja, da kan du bare ta den. Ja. Thank you so much for a great panel debate. It's interesting how just 30 minutes, all of a sudden, we were out of time and 30 minutes was passing. So a lot of nice things there, and I really like how you guys in the panel debate cherish the guys here doing the demos, the importance of them being here, using a lot of their work, using a lot of man hours to showcase these solutions to us. So that is so important, and we are so appreciating that. Big applause for the panelists and the demoists. So now we have 2 companies left running demos. And it's, this is the longest time you're in this room together. I know it's a bit long, but we needed to do it so that we could give everyone space. So now we have 2 of these. They will have 20 minutes each before we have a break. First of all, we will have Aucotec. Aucotec will showcase digital twin workflows in Greenfield based on standards like DXP and Automation ML with the comprehensive application of EMF types. Additionally, Aucotec's new AI-based approach to create functional digital twins by the import and processing of non-intelligent documents will be introduced. Please welcome Anders Høie, Benham Gaharman, and Henry Block from Aucotec. Warm applause.
Okay, we will have our slide and live demo ready soon, but until then I will just start. My name is Anders Høie, Key Account Manager for Aucotec Norway. And some information about our company. We are Aucotec, a German company founded in 1985 in Hanover, and we have subsidiaries all over the world, including Norway. We are 250 people, and we have a healthy economy. And one big advantage for Aucotec is that our whole company is focusing on one product, engineering base. So everybody in Aucotec is working hard to continue our success with engineering base, and we have more than 100 engineers and developers who are responsible for every aspect of engineering base. And process plans is a strategical focus for us. You can now see some of our references, like Kongsberg, we worked with since 2015, and ABB since 2015, and Equinor since 2019. And we always build long-term and trustful partnerships with great companies. And also for the other organizer companies today, Aker BP, Able, Aker Solutions, we really appreciate the opportunity to meet you face to face and have interesting talks. And we are greatly thankful to be part of DISC. We believe our day-to-day work is 100% relevant for the DISC initiative, because we're working with digitalization. And when you are using engineering base, you are working with data and objects instead of documents. So for example, with a pump, if you make changes to the pump, you're actually changing an object. And then all the diagrams and all the PNIDs where this pump is represented will be automatically updated. So you can see immediately how your work and how your changes will affect the project, because you're working with one single source of truth. And by working this way in engineering base, you are creating a digital twin. And every time you do more and more work, you are making the digital twin more and more rich with data and useful information. And we are an innovative company, so of course we will talk about AI. And to present this is our Head of Product Management, Dr. Henry Block.
Thank you, Anders. A warm welcome also from my side. I will keep this slide for one more second or a bit more, just to emphasize on we can only do AI if we have correct and structured and nice and high quality data. That's the core for everything. We heard it earlier this day. If we have just data, put AI on top, then we have crappy AI output. If we have structured data, we put AI on top, then we get the best results out of it. We're working on two parts of AI at Aucotec at the moment. We see the overall really importance of AI. The current focus lies on something that we call the, we focus on migration of legacy documents. If you have something in PDF or PNG format, how we can transfer this into the EB data model and not just the pictures, really into that and have a functional digital twin. That's currently under development. I will go into detail a bit later. Upcoming, we are planning to use generative AI. Our idea is to convert the whole data model of engineering base into prompts and into a data model that has semantics and attributes. So any system has a pump with attribute X, Y, Z, and then we can train this model on the semantics, on the attributes, and have prompts to interact with this, to auto-fulfill, do some questions, some queries, find quality, have quality control tools on that. But let's dive into what we have under development right now. You can see here that on the upper corner, you see a non-intelligent document, so PDF or JPEG. We have something that's a pre-trained model. We focus currently on PNIDs that can then run on these PDFs or JPEGs and identify the shapes on it and all the additional information like tag numbers and additional piping class or whatever is text-based information. We map this to the real objects in engineering base, and you will get as a result a flat list of all the objects within this PNID. So no more re-engineering of legacy documents. We know that this is just then the information that is covered within the PNID, but we need maybe more and additional information. And therefore, we already have for other formats the way that you can add additional information via Excel or other formats that you can import. And then we can combine it in EB. In EB, we will have then in the background the picture, so the PDF, and hotspots on top of it, so you can directly navigate through the whole system. Benham will show also the navigation in EB in the live demo. So this is what we are focusing on AI at the moment. We don't have it live here, but we have a video on the booth, so I invite you to come there and have a look. Now, before we go into the live demo, we don't want to spend too much time on slides. Let's do a short recap of last disk event. We are nearly the same team again here, again 6 people from Aucotec. We demonstrated last year a lot on DEXP. So we thought we did it last year, let's show you something different this year. So we will not emphasize on DEXP this deeply today. Today's focus is on IMF and AML, and as in last year, little spoiler, we have a bonus at the end again. Last year it was IMF that we showed that we could connect live. At the very end, today we have something special. So keep focused and wait for the very end. So with no further ado, I would hand over to Benham to go into live demo then.
Thanks, Henry. So I guess you guys can hear me, and I hope that you're still awake. If not, at least for me, that is the fun part. Okay. That can happen during a live demonstration. We've been kicked out. The demonstration that you will see today is not on my local system. It will be running on a Citrix environment. So, can happen sometimes, but we're here already. And let's switch back one more time to the PowerPoint, and let's have a look on the exactly. To the live demonstration part. So we have 2 main showcases that we want to demonstrate today. One is the IMF type integration. So we will be connecting live to the IMF PCA library and synchronize the IMF type definitions. The second part will be the AML import. But as you can see during the live demonstration, there will be also other topics that I will show you. So I will guide you through the demonstration, and there will be a lot more than just the IMF type definition synchronization, or let's say import, and the AML import. All right. So now, no. Here we go. This is our user interface of EngineBase. So when I'm talking about EB, it's short for EngineBase, so that you know what I'm referring to. The basis for the, as you can see, let's zoom in a little bit. The basis, or let's say the digital design basis for the demonstration is the Munin project. That is the digital twin that we have. So we have already some data inside of our database as part of the project. And the structure that you will see during the demonstration, as you can see here, this is the best practice from Equinor. It's also used in the Spine project. And same for the other aspects according to the ISO 81346 standard. So we have the equipment world, we have the system world. Also here, this is all best practice Equinor, the locational aspect. And of course, also the documents. I will just open a worksheet. The worksheet is something really mighty in EngineBase, so we can see all the content. It's kind of a query over every information as part of the project and the database. So in this case, I'm interested in the documents that are available in my project, and I can immediately see that we have already a PIN-ID, we have a SCD. Let's show this. We have a preview here. So this is a short preview of the content. the pin ID and the SCD. So that's, again, that's a digital design basis, but the first step, or let's say the first showcase, is to import data from the PCA library, from the RDL, and therefore we will switch in the same environment. We will have a look into our catalog environment. Here we can see that there can be different materials and catalog data available. So if I open the materials, I can already see that there are some already some IMF type definitions there. Also with the substructure, we will see that later on, and all the attributes that are currently available in the RDL. So also for the system part, so the different type definitions are available, and plus, of course, the material, the catalog, will consist also data coming from contractors, for example, from manufacturers. This is everything part of the catalog environment. This is, by the way, something that could be also similar for EQ Hub, to really have manufacturer data available and to enrich the data set and the databases that we currently have. So let's start the IMF library update, and immediately you will see in this corner here, of course, it always depends on the internet connection, but now we have a live connection to the IMF library, to the PCA RDL, and can select between the different IMF element types. So we have the blocks, terminals, attributes. For now, we will stick with the blocks. And this is an improvement to the last time that we showed our IMF library assistant. A few things that you will see. We have now multi-selection, so I can, let's go for the pipe, plant, product aspect, and the sensing element, which will also be relevant for the further demonstration. So when I press synchronize, you will see that the database and my catalog will be enriched with the data coming directly from the library, from the RDL, and it will show me what is the status. So it's synchronized, the specific elements. Now it's done. We have, of course, a mapping, but that is something, if you're interested in that, we can show you later in the booth. Let's go for one specific one, the sensing element. So similar, it has a substructure and also the complete set of attributes that are part of the IMF type definition. So I can also open it in a separate dialog and see the IMF attributes. There's also, so as far it is, of course, available in the RDL. There's also a URL that's also part of the attribute set of this instance, or let's say of this object. I can navigate, open it, and I will be directed to the PCA environment. The internet is not too fast here, obviously. Let's give it a second. Yeah, and this is the RDL that we see. We have the sensing element, and all the definitions of this object can be seen here. So the task is now that we have enriched our databases, design bases, to use that in our project. So therefore, I will go back to my Munin project. And as we have seen before, I can open a worksheet for specific content. In this case, we will look for run a query over the database, the project, regarding the sensors. These are the sensors that are available in Munin so far. And from here, we can, since we're using the architecture, the philosophy of engine base of EB is to have a single source of truth. So we don't have different databases that need to be synchronized and harmonized. We have one single database where every of your engineering data, the project data, is available. So let's choose one And from here, even from here, I can navigate to the different aspects of the object. I can even see that there are some associations, so some representations of this specific instance on drawings. In that case, we have an SCD and a PNID, but I want to navigate into the tree. Here I can also see the complete substructure, the associations as well. And now we want to enrich this instance, this instrument, with the information that we just got from the IMF library. The sensing element, there's an overview about the content, the information that is available. Press OK. And you will see that, again, single source of truth. It's not only updated on the object itself, but of course, because we are looking at the same source, same data, it's already here synchronized. Then, furthermore, related documents. We can see also in this view that there are different documents related to this object. And furthermore, the functional aspect can be shown, can be made visible in parallel. So let's navigate to the PNID itself. The relevant object will be highlighted. Let's zoom in. And even here, this is not only a shape, it's not only a symbol, it's a, so maybe for those who want to have a look on the beauty of this PNID, which is coming from the Munich project, but let's zoom in again. This is only a representation of the object, of the instance. So even here, I can navigate, it's kind of a neural system. I can even navigate here from here. If there's a representation on the SCD, which we have, which is available, I can navigate directly there or to the different aspects of the object and even have a look into the attribute set of that object. So that's valid. That's the same way for other objects. Let's have a look. We have seen that several times, mentioned pump. Maybe probably a few more times you will hear the pump example. And also here I can, same story, open the dialog. Of course we have different attribute set here. That is in EB, it's completely flexible according to the requirements of your project. So the properties, the information that we require can be adjusted here. We have also for the pump some process data. The volume flow currently is at 6.7. Why do I mention this? Because this will also be part of the further progress of the presentation. So keep in mind that this specific value has been changed to 8.8. Okay, and then from here I will navigate to the SCD. Again, the object will be highlighted by the system. Let's zoom in. Same story here, it's just a different representation. And we also have, of course, on the SCD, we have some function blocks. So different object types. But even here on the object types, as far as the data is available, we can navigate to the different aspects and data of this object. Another thing, I know I want a lot from you, but please keep in mind that this value here, which is, I can tell you that's a representation of the node reference, so the source information will be visible here in case it is available. Currently, it is not, as we can see. We have no node reference currently. And that will be part of the next showcase. Let's also see that there is no information, revision information so far. That will change in a moment. But before that, let's go back to the pump, and navigate back to our tree. Related documents as well, substructure, similar way. and let's create on the fly a pump data sheet. So this is based on a template that can be according to a project or to a subcontractor, manufacturer, whatever it is at the end, what you require. Let's give it a name. And create the data sheet. It will be, as you can see, this is again now part of the substructure of this instance. It's associated, and we can also now see that it will appear in the related documents. So no need to actively update the environment or anything. This is single source, true single source. Let's open it, and let's see what we have. This is the information that is coming from the instance. So here, as I mentioned before, you can now see the updated value on the data sheet. So whenever you change a value, it will be propagated to everywhere this information in your project in the database is used. So far, so good. Next part will be the AML import. Therefore, I will start on the project, I will start the AML import assistant, and this is already selected. This is the file that was provided. This is coming from Munin. We have a specific mapping. I will just press import, and the data will come in. In the meantime, let's have a look into the AML that we got itself. As we can see, we have the SCD collection here. We have the Munin specification. We have the different objects here, also the function blocks, this one that we just saw, also the attributes. I'm not an AML expert, but this is at least we can have a look into the content that we have here. Yeah. Let's switch back. Maybe furthermore to see what we got as a basis. This was last year. The demo content, the PDFs that we got. So as Henry mentioned before, this is something that could be coming from via AI. This is what we got. Of course, nothing that you haven't seen yet, but just to show you again the PDF and the way it also looks in the application itself. Please also keep in mind that we are currently running on a Citrix environment, so it's not on my local machine. So it will take a moment. It depends on the internet connection, and of course also the amount of data that you want to import here. We have about, 2,000 objects here, 1,800.
Okay, we are getting into the timing here now.
Okay.
I need to be strict. I'll give you 30 seconds.
Yeah, usually, I mean, usually it runs faster, to be honest.
Okay, 20
but
seconds.
It is what it is.
20 seconds.
20 second summary. So engineering base is this open ecosystem. It can be used by owner operators, EPCs, and contractors. And we are working with AI and IMF, and we support DEXB and AML. And for all these topics, we would love to go more into detail at our booth or in separate meetings.
Great.
Of course, especially the further progress of the demo would be data tracking, so we can have a talk at our booth. No bonus system.
Thank you, Aucotec, for a perfect presentation. I'm really pleased, and we are pleased actually to see that you're utilizing IMF framework together with AML, putting it into your engineering tools, but also utilizing AI. And I think it was a perfect kind of transition and answering some of the requests for the panel debate. So thank you.
Thank you.
Great. Okay, and before we welcome Siemens, in the heat of the moment, I forgot to give the flowers to the panelists and the moderator. So please, if you're still present, I can see Kjell, you are here, and the others joining the panel, could you come forward to the stage so we can give you the flowers?
Can I just unplug that one here?
What's that? I think we need to get some of them to the others in a later stage as well. But thank you so much, Ellen Kristine, for participating. Yeah. Okay, this one. And Kjell. That's good. Thank you so much.
Yes.
So, welcome Siemens. I think you can just introduce. It's okay. You can
Thank
start.
you.
Yes.
Good afternoon. My name is Helgi. I'm with Siemens for a couple of years, and I hope you still are energetic enough to stand another demo. Yeah? So what I will conduct today, or what I would like to show you today, is our interpretation of data. Give me a second here. Yeah. Just a second. The presentation mode here we go. So, small introduction to us, to me and my peers, which are sitting here in the audience, on our business unit within Siemens. So we are part of Siemens Digital Industries process automation software. And Siemens probably might be well known amongst you as a vendor of hardware, systems, applications, devices, and so on. But we are also having a quite big software branch. So it's not about physical devices, but also delivering and providing software applications and solutions. And me, in particular, today will talk about our, let's say, our computer-aided engineering application, COMOS, lifecycle information management system, which is a little bit indicated over here in the lower left corner. And our interpretation on how to take on the show-and-tell data, which were coming from Hugin and Munin. A few words on the use case that I'm trying to present here. Actually, it is about the idea is how to hand over engineering design packages and how to hand over engineering design data from different EPC contractors and make that reusable for, let's say, an owner-operator of a system in a system like ours. So what we got actually is a bunch of information in different formats. You could write, you see here on the right-hand side, so we got PDF, AML data, DXP, XML data from the two systems, or from the two facilities. Yeah? And the idea is, okay, how can we bring that together and make sense out of it? Yeah? So obviously you're doing that for a purpose. So one thing is obviously to get the information into your systems, so to load, maybe post-process them, in a sense that you need to validate and cleanse what you got. You might want to merge information or reference or contextualize data to make sense out of it. Yeah? And then obviously it's about visualizing this information, but later on also maybe modifying or editing it, yeah, from an authoring perspective. And then using the intelligence of the data to let's say, provide certain capabilities or features like interface management. Yeah, that was a use case that was mentioned in the preparation meetings that we had, yeah, as part of the digital engineering. So how can we do interface management on that one? And then maybe eventually also how to, in terms of interoperability, how to connect to backend systems and provide data sets from the engineering applications into operations or other business applications. That's the end. So a little bit on the data model. That is actually the underlying foundation or basis. So what we are providing is a data model that actually I always like to say we create items in a database which are representations of physical items out there in your facilities or in your projects when you're still in the planning phase. So it's a digital representation of a single item. It has a unique tag ID. It might have unique attributes or design parameters, or maybe even later on life cycle and operations attributes and parameters. But in the end, it's unique. You can provide different views to that item. So you can have an electrical view, instrumentation, process, automation view, mechanical view, if you like, or later on in operations, maybe even having a perspective or a view on operations or life cycle data that might be associated to an item in its life cycle. It can have different representations, so it can be represented on PNIDs, it can be somewhere on function diagrams. You can link it to items in other systems, so that's actually the single point of truth that we have heard already before. The data model, I think that's important to mention, since we are not talking about the authoring of information here as much as I think the data model needs to come with the flexibility to be able to link to all kinds of standards when it comes to data exchange. Yeah? We were talking about standardization a lot. We were talking about data libraries or reference data libraries that are coming with DEXB, with CFOS, with all kinds, you name it, what you have, right? And that is, I think, this flexibility comes with the Cosmos data model as such. So, what did we do? Let's start with the easy part. We were loading AML data from the files provided for both systems, Hugin and Munin. Yeah, and that is actually quite easy. So what we did over here already is that we can then here have a plant breakdown structure. We just made a mock-up or a representation of the plant actually. So that would be the place where all the information from all the individual contractors, from all the system providers would be merged. So what we got here is then somewhere a node which would hold all the INC data. Yeah, so we can create loop representations. We can create a device, as it is called, I believe, in the AML, and we might have then function blocks information over here, but also the corresponding signals and maybe data that are coming with the signals. Yeah? So that could be like thresholds or limits or whatever, what type of output or input it is. So that's coming with it. And we did that for both Hugin and Munin. And now just to give you a little bit, let's say, my perspective on the data, because we as a software vendor, we obviously have a challenge because all the clients and say, okay, well, what standard do you support, right? And why are you not supporting my standard? And you have DEXB, but my DEXB looks different, or my AML looks different, right? And that is always a challenge that we are facing. So just to give you now, let's say, my assessment on that information, so far we got it, was that on the AML portion at least, we had a very good fit between Hugin and Munin. So we could run one importer actually, more or less. I think there was only two minor differences between the data sets provided between Able and Acre actually. And that was that I think the function blocks were called differently. Yeah? So there was a quite good fit, and we could run one importer script to actually provide all the info. Although we were not getting the connectivity data in. I'm pretty sure they were not provided with Acre, with the Hugin data set. I'm not quite sure about the Munin Able data set. And logical operators and attributes, at least for Able, were not provided yet. Yeah? But in the end, I think it was a good fit, was a good mapping, and a good match, sorry. Yeah, so then let's come to the next step, how we get data in, and that was now we got different DEXB PNIDs provided. One was the Hugin PNID for this rich tech search drum, I believe it is. So we were focusing on that system because I was looking for data sets which would actually match together, which would allow me now to bring all the different sources together. But we also got the Munin DEXB in. Yeah, and there was now some differences that we can, I believe, that is something we can distinguish. Although there is maybe something where the industry also maybe needs to realign or align a little bit more on making it easier for us vendors actually to support these standards from that perspective. Just to show you what we got in. So from the Hugin PNID, I have now here a representation of that import. So what it gives me is actually it identifies the elements according to the DEXP class library. Yeah, so I can identify elements over here. Pipe structure, I believe, is very important. Yeah, and I think what we are doing here is getting the data in. No, sorry, for the Hugin, data were not provided, but I think they were intentionally scraped by Acre when providing the data sets. Yeah, so potentially I could now also identify elements over here. No. I could identify elements over here like data sets that were coming with the items, but they were scraped by intention. Yeah, so we could actually not really use much of the data that were coming in through the DEXP. But anyway, for the Hugin pin ID, give me a second. Sorry, for the Munin pin ID. I always mix these names up. Yeah, so that is now actually our import of the DEXP Munin file, Munin pin ID that we got in. Also identification of the items as per DEXP class library. Yeah, so that is something that I can reuse. And we also got data coming in from the authoring application. Yeah. The only thing is we did not map it now to the COMOS attribute yet. Yeah, but in the end, that is a part of the post-processing procedure that you can then run, let's say, scripts or methodologies to map certain attributes to the hosting data model, if you will. Yeah, and when you have done that mapping once, then obviously you can reuse that in a project. Yeah, but from that perspective, the information handed over was quite okay. The only difference that I could see is, and that is something that was already mentioned today by that was mentioned by the gentleman from Plans and Bytes. I believe the major distinguisher here between Hugin and Munin was the symbol library handling. Yeah, for the Munin, there was a reference to a symbol library, and for Munin, for Munin was a reference to the symbol library, and for Hugin, we actually were taking on the original graphics as created by the draftsman. Yeah? And I think the gentleman from Plans and Bytes elaborated on that topic here in particular, but that is something that you need to align on. Yeah? But in the end, we were now getting the data in. Another stuff that we got in, and that was just on short notice, we got an DEXP export from an SCD into, from Zemantum. Actually, they were just 1 or 2 weeks before the show providing me a DEXP file of an SCD in this case. Yeah, so that was actually a representation over here. And I was actually quite amazed when I found what I got. So what I got is actually already from the piping information already mapped to the DEXP class libraries and to the valves. The function blocks over here that were actually not defined. So they were just, let's say, dummy import objects, so to say. But what we could do is we could identify the graphics and map it to what we were interpreting as a function block over here. Yeah? So, and now there is now the challenge, or let's say, one step, obviously, when you merge all that data is how you want to validate and check what you got. Yeah, and bring that together. So what we did now, with these three information that we got DEXP pin IDs, we got AML, and we got an SCD DEXP coming from a PDF. We were now creating some validation queries over here. Yeah, so what it shows me here is actually all my instrument bubbles coming from the original DEXP. This is for Hugin. Could do the same stuff for Munin, obviously. Yeah, then I have the information on which pin ID it is placed. I have the function block coming from the AML import. I have a function block, because this is only a graphics yet, on the SCD. Yeah, and this allows me now to filter here, run a small validation routine over here to show me, hey, what information is now placed on both the pin ID as a function, as an instrument bubble, coming from a function block, referring to the same device in its AML, and a graphical representation on the SCD as such. And now I can say, okay, I have a validation script over here, so I can see that I have a pretty good fit, which is actually not a big surprise, because both the AML was both derived in this particular case from the SCD, the original SCD, yeah, which was a smart document in the database, and then later on just turned into a PDF. So I have a pretty good fit, and I can merge the information over here. Yeah? This allows me now to merge the information and actually, yeah, let's say merge information and bundle them in the form of what I was describing as an object before. Yeah? So I will not do that now, but this allows me now to again create from external data, let's say, this single point of truth approach that I was, and I was actually quite amazed that I could turn the PDF SCD back into a smart schematic then again, yeah, with all that representation. So that requires maybe still a little bit of touch-up, was a pretty good result. Yeah? Kudos to the Semantum guys. So, and then the time is running. Another use case was then on interface management. So we understand that there is a challenge now to check information between on the interface, on the tie-in points of the different projects. Yeah, so I have these off-page connectors between the Hugin and Munin pin IDs. Yeah, so they refer to each other, but right now they are only references. And I understand that it is a challenge if you have hundreds of these guys that you need to check the specs. So when you have a connecting pipe over here, does it have the same specs as the receiving pipe, so to say? Same rating, same connection, same flanges, same whatever. Yeah? Fluid codes, and so on and so on. So what we were doing, we were smartening up these off-page connectors. We created kind of interface objects out of it. We maintained the symbol graphics, but we were then collecting here, let's say, information. So we were referring these off-page connectors to each other through a simple rule. Yeah, so go into that pin ID and find for an off-page connector, and then look what pipes are connected, yeah, and get me the data for that pipes. So are the diameters the same, are the ratings the same, are the flange connections the same? You can apply that methodology also, if you like, on instrumentation. Not sure if electrical cables or something like that would be an option. Anyway, just thinking out loud now. And what you then got is, let's say, an overview here, which would show you clashes between these two items that are connected in the database. Yeah, so it's a kind of contextualization and, let's say, making information, or yeah, contextualization, and that's actually making things smarter, right? So, and since I do not have too much time, I will quickly show you the result. So that is a little query routine that we built. So I have on the left-hand side, I have now my off-page connector on that particular pin ID with that pipe connected. We just placed here some sample parameters. Yeah, since we do not really get project data through the Hugin pin ID, we just created our own ones, but I think the concept should be clear. So I can now monitor the interface attributes here on that level. Yeah, if I make that a little bit smaller over here. Yeah, then I have here on the other side, on the receiving side, I have the off-page connector. Sorry, the other off-page connector on the other on the Hugin pin ID, with that pipe connected, and these parameters over here. Well, we gave it a little color change to indicate a clash. So in case I change that parameter here to a matching one, the color change will disappear over here. Yeah, and that's this one remains. Although you can obviously extend that and then have more representative parameters over here, but I think that was just a little bit an indication, and that was our interpretation on what we understand with the interface management in the in the preparation meetings. So, 30 seconds over.
So thank you, Siemens, for an excellent presentation. A couple of points there I would like to kind of highlight is what you in kind of introduction is about the standardization and all the standards out there, as you mentioned.
Exactly.
And it's a kind of feedback to us as well, because we have on our activity list that we have to look at DXP and IMF and align those kind of standards.
Correct.
The other thing is interface management. I think it was a brilliant way of presenting and how you actually have developed that interface management. So thank you.
Thank you. Thank you very much. Good.
Thank you so much.
If you have any questions on that one, I'm still standing there at my table.
I'm so sorry you didn't get the introduction.
No problem, no problem. It was a short one anyway.
Thank you so much.
Thank you.
Okay, so now we're going to have the last break before the 2 last demo sessions. It's really important that people stay present because the people doing the demos had put a lot of work into this. So stay present for the day, and after that demo show, we will have the rewards and the prizes as well. And that will be a lot of fun to see who will win this Show&Tell 2024 competition, friendly competition. And some food for thoughts again before we head into break. If you see this picture here, there is a guy with some heartaches. And I used to work in healthcare many years ago. And when I worked there, they told us that people with severe heart diseases needed to do nothing physically. They should just rest. I did that. I recommended that to my patients. And now, 10 years, 15 years later, we know that they need to have moderate physical activity to actually have great health. That is one reason why I'm showing you this. Things are changing, times are changing, but also I think it's really important that we look to other industries for knowledge sharing, that we break down the silos. I can for sure say that many of my experiences and knowledge working in the healthcare sector, I brought into this industry. So again, it's all about the bigger picture and try to look out there in the horizon. Have a nice break.